Alright, so in this example we're going to be looking at a second order linear non-homogeneous differential equation y double prime minus 2y prime minus 3y is equal to 2 times e to the minus x times cos x plus x times e to the 3x. Right, to solve a non-homogeneous differential equation we've got to go through a two-part process. The first part is to find what's called a complementary function. The second part is to find a particular integral. So let's start with the first of those, the complementary function. So the complementary function is found by solving the above problem, but where the right-hand side is 0. In other words, where y double prime minus 2y prime minus 3y is 0. Now we go about solving this homogeneous problem by solving what's called the auxiliary equation. And this is obtained by replacing derivatives of y with powers of m. So in this instance, the y double prime gets replaced by m squared, the minus 2y prime gets replaced by minus 2m, and the minus 3y just gets replaced by minus 3. So our auxiliary equation is a quadratic shown here, which can be factorised into m minus 3 times m plus 1. And this of course means that the roots of this quadratic are m equals 3 or m equals minus 1. Now we can take these roots because they're real and distinct, and we can form a complementary function which we'll call q, and that's going to be equal to a constant a times e to the 3x plus a constant b times e to the minus x. The exponential of 3x arises because one of the roots in the auxiliary equation was 3, and the e to the minus x arises because one of the roots in the auxiliary equation was minus 1. Having found our complementary function, we now need to try and find our particular integral. So to find a particular integral, what we do is we look at the right-hand side of a non-homogeneous equation and try and construct a general form that's similar to that right-hand side. So if you notice, the right-hand side is made up of the sum of a couple of functions. The first of which is a product of an exponential function with an argument minus x multiplied by a trigonometric function whose argument is x. There's another function which involves the product of a polynomial of degree 1 multiplied by an exponential function of argument 3x. So what we do is we try and construct our particular integral to be the most general form of what appears on the right hand side. So for example, we'll try our particular integral to be e to the minus x times a sine x plus b cos x plus cx plus d times e to the 3x. So the first collection of terms on the right hand side involves the product of an exponential function whose argument is minus x with some trig functions, and the second term on the right hand side involves the product of a polynomial of degree 1 with an exponential function whose argument is 3x. And this is, if you like, the most general form of the right hand side of a non-homogeneous differential equation. However, this particular integral isn't going to work, and this is because on the right hand side of on our function p, our particular integral, it contains a term here which involves a constant multiple of e to the 3x, principally this d times e to the 3x. Now, if we can recall, our complementary function involved a constant multiple of e to the 3x. This means that in our proposed particular integral, there's also a term that features in our complementary function. That alone will guarantee that our proposed particular integral p cannot satisfy the non-homogeneous differential equation. What we have to do in that case is to multiply the offending term by an x. So in fact, our particular integral ought to be p equals e to the minus x times a sine x plus b cos x plus cx plus d all times x times e to the 3x. This way, there are now no terms in our particular integral that also feature in our complementary function. So let's try and consider what these unknown constants a, b, c and d are in our particular integral. And we do this by substituting for p into our non-homogeneous differential equation. So since the non-homogeneous differential equation involves derivatives of p, first and second order, we've got to work out what p prime is and also what p double prime is. So let's differentiate our particular integral p. We've got to use the product rule on a couple of occasions, and you can see p prime is given It's given in this line here. Now what I'm going to do is I'm going to collect all the terms involving e to the minus x, and I'm going to collect all the terms involving e to the 3x. So this gives us our p prime. Right, we now need to work out what p double prime is. So again, we've got to differentiate p prime using the product rule. And this is shown on the current line. As before, we're going to collect all the terms involving e to the minus x and all the terms involving e to the 3x. So we now have expressions for p prime, and p double prime. Let's replace the y in our original second order non-homogeneous differential equation by p and see what we get. So p double prime minus 2p prime minus 3p is equal to the expression on this screen here. I've collected all the terms involving e to the minus x, and I've collected all the terms involving e to the 3x separately. And if we now simplify these expressions, we see that p double prime minus 2p prime minus 3p is e to the minus x times minus a plus 4b times sine x plus minus a minus b times cos x plus 8cx plus 2c plus 4d times e to the 3x. And this right-hand side is what we want to compare towards. In other words, we want p double prime minus 2p prime minus 3p to be equal to 2 times e to the minus x cos x plus x times e to the 3x. In other words, we want to satisfy the equation shown here at the top of the next slide. Now, what we're going to do is we're going to compare terms on the left and on the right-hand sides of the equation, starting with terms involving e to the minus x sine x and e to the minus x cos x. So if we look for terms involving e to the minus x sine x on the left-hand side, we get minus a plus 4b such terms. On the right-hand side of the equation, we've got nothing. No terms involving e to the minus x times sine x. So that tells us minus a plus 4b must be 0. Similarly, if we look at terms involving e to the minus x times cos x, on the left-hand side we've got minus 4a minus b, and on the right-hand side we've got two lots of such terms. So minus 4a minus b equals 2. And of course, what we've got here now is a pair of simultaneous equations. Let's multiply the bottom equation by 4, then add the resulting equations together to see that minus 17a is equal to 8. In other words, a must be minus 8 over 17. Now, since we know that minus a plus 4b is 0, that can be rearranged to say that 4b is a. In other words, b is a divided by 4, so that ensures that b must be minus 2 over 17. It's left now for us to work out what the constants c and d were in our particular integral, and we can do this by comparing terms involving e to the 3x in the equation at the top of this slide. So on the left-hand side, the multiple of e to the 3x is 8cx plus 2c plus 4d. On the right-hand side, we've got x lots of e to the 3x. So that tells us that 8cx plus 2c plus 4d must be equal to x. Now if we compare coefficients of x in this equation, we see that on the left-hand side we've got 8 times c lots of x. On the right-hand side we've got 1 lot of x. In other words, 8c has got to be equal to 1. c has therefore got to be 1/8. If we now compare constants on both sides, well, constants on the left-hand side were 2c plus 4d. On the right-hand side there are no constants, so that tells us that after a little bit of rearranging, d has got to be equal to minus 1/2 c. Because we know that c is 1/8, we can see therefore that d has got to be minus 1/16. So we now substitute in for a, for b, for c and for d into our particular integral to get that p has got to be e to the minus x times minus 8 over 17 sine x minus 2 over 17 cos x plus 1/8 x minus 1/16 times x e to the 3x. Finally then, to get the general solution for our non-homogeneous differential equation, all we've got to do is add together the complementary function q and our particular integral p to get our general solution. So if we do that, we see that our general solution y has got to be a constant b minus 8 over 17 sine x minus 2 over 17 cos x times e to the minus x plus 1 over 8 x squared minus 1/16 x plus a equals e to the 3x, where capital A and capital B are any constants you like.